everyone, welcome back to Pepcoding. So the question which we will discuss today is known as negative cycle weight detection. So first let us understand what the question wants us to do and then we will head over to the solution. Okay, so we have been given a directed graph over here. You have to figure out whether it contains a negative weight cycle or not. So the first thing which we need to know is what is a negative weight cycle. We all know what negative edge weight is, right? For example, in this case, the vertices 1 and 4 have an edge between them whose weight is -5. So we know what a negative edge weight is. But what is a negative weight cycle? A negative weight cycle is a cycle which is present in a graph, the sum of whose edge weights comes out to be negative. So for example, in this graph which we are talking about right now, between the edges 1, 2, 3 and 4 only. If I say 2 plus 3 plus -4 plus -5, the answer which I'll get will be -4, and -4 is a negative value, right? So this is a negative weight cycle. So this is what you have to do. You have to figure out whether there is a negative weight cycle present in your graph or not. What we are going to do is we are going to use Bellman-Ford. Now Bellman-Ford has been discussed before this question, so if you haven't watched the video for it and if you haven't solved it before, I'll suggest you to go and please try it out, watch the video, understand the algorithm, because this question is an application of Bellman-Ford. If you won't be able to understand the basics of Bellman-Ford, you won't be able to solve this question. Okay, so assuming that you've already watched it, the video for Bellman-Ford, we are going to work with this question. So the thing is that Bellman-Ford does not work for a negative weight cycle. Alright, you cannot find out the shortest path for a negative weight cycle. What is the reason? See, you have, let's say I want to go from 1 to 2 and I want to find out the shortest path between 1 and 2. So one path is 2, right? The other path is if I go in a cycle over here, something like this. So what will be the sum? 2 plus 3 plus -4 plus -5. So it will come out to be -2. So that is a negative value. You got -2. You will assume that that is your shortest path. But it is not. If you go in another cycle after it, you will figure out that the next value comes out to be even smaller. So when you're working with a negative weight cycle, you have to go into infinite circles to be able to get your shortest path. So what Bellman-Ford does for us is that if it comes across a negative weight cycle, it will simply detect it and tell us that, okay, this is a negative weight cycle, I cannot work with it, I am not able to find out the shortest path for it. So if you find out a negative weight cycle, over here, we will return 1. Okay, otherwise we will return 0. Now see, in Bellman-Ford, we discussed that we take v-1 iterations, where v stands for the number of vertices. What is the reason behind taking v-1 iterations? That for a cycle, we do not get the optimal solution. So if you want to get the optimal solution, you have to take v-1 iterations. So if you have a negative cycle present, it will be rejected, and if it is a positive cycle, then you will travel linearly only. Alright, so you'll get an optimized solution. Another thing which we need to talk about is that when we were discussing Bellman-Ford, we discussed that the maximum path length is equal to v-1, right? But when you are working with a negative cycle now, you will figure out that the maximum path length can be v plus 1, v plus 2 until infinity also. See how? You have to go from 0 to 2. Okay, let's suppose we have to go from 0 to 2. What will be the shortest path? We can go in a cycle. 1 plus 2, 3. Plus 3, 6. -4, 2. -5, -3. And -3 plus 2 is -1. Then you can go in another cycle also. So first we had -1. Then from this point, we can go in another cycle also, right? So minus 1 plus 3, minus 4, minus 5 plus 2, right? What will be the answer for this? It will be equal to minus 9 minus 10 plus 5. It will be minus 5. You have an even smaller value than the previous value. So every time you'll go in a cycle, right, you will find a smaller value than the previous one. So if you go for infinite iterations, you will get the shortest path then only. So what we do using Bellman-Ford in this case is that we will take v minus 1 iterations just like we did in Bellman-Ford. Then after exiting this loop, I will go for a vth iteration also. Okay, and I'll find out whether my value is being updated or not. Okay, so if the value is being updated, then we will return 1, because that means if for vth iteration I'm able to update the value, that means I've entered a negative cycle. All right, and if you do not have the value updated, or it is not possible to update the value anymore, then we will return 0, because that means that there is no negative weight cycle present in the graph. So this is what we are going to work with when we are going to do Bellman-Ford for this question. Now see, over here we'll work with the code. Okay, so the first thing which we need to do is we need to create a path array. So int path equals to new int n. Okay, and we need to fill it with infinity. So arrays dot fill path comma integer dot max value. Okay, and we put path of 0 as 0 only. So this much work we've done. Then I need to assign u, v and weight, that is the two vertices and the weight between them. So for int I equals 0, I is less than n minus 1. This is for v minus 1 iterations. And for int j equals 0, j is less than edges dot length j plus plus. We have a value u which is equal to edges of j comma 0. Then we have int v which will be equal to edges of j comma 1. And finally we will have int weight which is equal to edges of j comma 2. Okay, the next thing which we are going to do is that I'll check that if path of u is equal to integer dot max value. Over here we need integer. That means if it is already containing infinity, I will not update any value. There is no use. You cannot update infinity, right? So we will simply continue. And if path of u plus weight is less than path of v, we will update path of v to be equal to path of u plus weight. Okay. Now this is what we do for n minus 1 or v minus 1 iterations. Next thing which we need to do is we need to work for the vth iteration, that is the last iteration. So let's see how we will do that. Over here, this is the fault. Okay, so we are working with our vth iteration now. Now if it is possible to update the value, we will not update it, rather we will simply return it, right? This is what we were discussing previously also, that if there is a condition that if I am able to update my value in the vth iteration, instead of updating it, I will simply return it. So I returned the value as return minus 1. And if I don't return 1, that means the negative weight cycle does not exist, so I'll return 0. So this should be the code. Let us try to run this now. Okay, so it is correct. We'll now submit this. Okay, so it is correct. So we discussed about negative weight cycle detection and we understood how we use Bellman-Ford for this question. I hope you understood the question as well as solution. We will see each other the next time. Till then, please like, share and subscribe to the channel. Thank you. So now we will try to run this. And we have an error. Let's see what it is. Okay, I did not put double equal to over here. Now we will try to run this and submit. Okay, so we got the right answer. So we were discussing about Bellman-Ford today. Okay, so I hope you were able to understand the question as well as the solution. And it is an important algorithm, so I request you to practice it properly. And the next question which we will do is an application of it. So please practice it properly. So thank you for watching the video. We will see each other the next time. Till then, please like, share and subscribe to the channel.